Let's answer this 5-part question on second derivative. So we have f of x. First one is asking us to use the first derivative to find the critical points. Write in order pairs. Okay, let's do that. So to find critical values, we start with the first derivative. So let me, you know what, maybe I can just copy this much. I'll do them down here, okay? Here's my problem. Where did that go? Right here it is. All right, so find the first derivative. F prime of x is 3x squared plus 2x minus 1. You set this equal to 0, and I think we can factor this. How, right? I think I'm going to do some factoring work on the side here, okay? So here's my scratch work for factoring. So factoring work. 3x squared plus 2x minus 1. I'll do my scratch work over here, okay? So I first multiply this 3 by this 1 and rewrite my trinomial into x squared plus 2x minus 3 temporarily, and I factor this. The only number pair that will multiply and give me 3 is 3 times 1. If I make 3 a positive, 1 a negative, they will add up and give me 2. So this is good. Now I divide both of these by that original number that I multiplied, 3. And if it divides, I will divide and simplify. X plus 1 is the first factor. But if it doesn't divide, I'm going to have to bring this bottom of 3 up in front of this x, like this. So the second factor comes out to be 3x minus 1. So that was my mini factoring work on the side. But now I got that factored. Uh-oh, hold on. Now I got this all factored out. Oh, goodness. I will write that down here, okay? X plus 1 and 3x minus 1. Because now I'm back to calculus, finding critical values. We're going to set each of these equal to 0. X plus 1 equals 0 will give me the first critical value of x equals negative 1. If I set the second critical factor equal to 0, 3x minus 1 equals 0. This will give me the second critical value of 1/3. And you know what, where that came from? Right there. If x is positive 1/3, wouldn't that give me 0 for the second factor? So we got the critical values. If they want us to write these in critical points, we have to find their y values. Critical points. First one is negative 1, comma, blank. And the second one is going to be 1/3, comma, blank. So this is where we have to plug into the original function. So I will need a calculator. I'll use a graphing calculator or scientific calculator to plug in. Let me start with negative 1, okay? What will happen if I plug in negative 1 there? Negative 1 cubed plus negative 1 squared minus negative 1 plus 1. So if I plug in negative 1, I get positive 2. So the first critical value is at negative 1, 2. Now let me find the second critical value's y coordinate. So I plug in 1/3 everywhere this time. And it came out to be I don't like that. I do want a fraction. I don't want that. So maybe I will go open up a scientific calculator because this one is giving me a decimal. Desmo Scientific by graphing calculator. So I'm over here on a scientific calculator this time. And I'm going to type that in. And this calculator has an option for me to convert it into a fraction. Yes, that's what I want. So that is 22 over 27. And that's what I'm going to write down as the y coordinate for the second critical value. So that was it for number 1. Okay. You know what? I think I'm going to create 5 separate videos for this 5-part problem. But this was the first part. We found an ordered pair for these critical points by setting the first derivative equal to 0.